What's up, everybody? Good morning. So I'm going to be talking about some things to sort of increase your contentment, your joy in your professional life. And if you don't like that, this talk is going to bring you down so much. So hang with me here. I'm going to talk about learning. We use this word a lot in our community, but we tend not to really think about it in detail. And so I just thought I want to take a few minutes this morning to be able to dive into what we really mean by learning. And I've been working on what I call a framework for learning how to learn. And that's what I want to kind of share with you a little bit of today. It's always good to start out with credentials so that you feel confident in what I'm going to tell you. And I also didn't learn French cooking. I don't know how to throw a football. But I have been working with students for about 15 years and in a variety of venues, one-on-one, in boot camps. I've been a professor at the University of Chicago, the computer science department, since 2013. So what I'm talking about is just my practical experience, not so much the theory. So your miles may vary for you. When I first got into programming, I was a speech major, and with which you can really do nothing. And so someone said, hey, you should go into some computer programming. And I was like, oh, great, what's that? It's really just about solving problems. Have you heard this? This is what we do? At first I was like, that's pretty cool. You mean like 6 times 3, or like how to organize a garage, or maybe, what's for dinner? Like I could solve problems like that. What they really meant, I think, is your job is to always be learning new things. If the problem that we have to solve has already been solved, they wouldn't need us. Right? We're there to solve something new, which always involves figuring things out. In other words, learning. And so I started to really think about this phrase, because this sounds great, but it's really not very good. What do we really mean by always learning new things? For that matter, like, how do you learn something new? So some people say, well, I read something and that's how I learn. So I listen to a podcast. I talk with other people. That's how I learn new things. I do something with my hands. If you want to make a ceramic bowl, you can read about it all you want, but you really got to get in there with your hands and get the experience. Lots of different ways to learn, and this is fine for casual conversation. But if our careers depend on this idea of learning new things, then we should really examine what it involves and what's required. And how many more times am I going to have to learn something new in my career? Like, can I please be done by now? But no, so it's just going to go on. And I thought, this is kind of funny. In the software engineering community, when we have to do pretty much the exact same thing, but a little bit different, time and time and time and time again, we tend to dry that up. You know what I mean? We don't like that kind of repetition. What do we usually do when we have a technical problem that gets solved over and over and over again, right? We like to have frameworks. We have, this is just off the top of my head. But our industry is filled with frameworks of different types to help you with different kinds of problems. And it occurred to me about a decade ago, we don't have a framework for learning, even though that is supposedly core to our profession. So what I want to talk about is this idea of learning how to learn. This is a very common phrase that's all over the learning sciences. There are books with this exact title, so I didn't make this up. I call the framework that I'm working on the aha map, because I suck at naming things. I don't know how you all are at naming things in your code, but I'm not so good. But it's just, my way of thinking about a series of principles that kind of interconnect that can help you figure out a reliable way to learn things. And so I'm just going to give you a taste of a little bit of it by starting with this question. How do we begin to learn something that is complex? If something is not complex, it's not worth talking about, right? You can just you learn it. It's when things are complicated. I remember first hearing about hotwire in Rails. I was like, okay, what is that? And it took me, I'm still trying to grok what is going on? You could probably think of whatever you are currently up against trying to understand. And the thing is that there are lots of cliches that abound to help us with this kind of thing. And I'm telling you right now, they're all lies. And I'm going to start to talk about the lies publicly right now. So here's number one. You probably heard it said, hey, you got a big problem? Just divide and conquer, break it into small pieces, things like this. And the thing about this kind of advice, which I give to my students, is that there's a kernel of truth in there. When you have something large, it is good to not try to figure it out all at once. We could go into the whole cognitive load theory, but I won't waste your time with that this morning. It's good to break things into small pieces, but again, I'm left wanting here because this avoids some of the important ideas about breaking something into small pieces. It sort of assumes that once you have all the little pieces, they are all equally easy to solve, and the order doesn't matter. Just solve them, and then you're done. It's not really quite true, in my experience. I was trying to actually help a friend of mine who grew up in Indiana, which I guess is football country, and I'm in Chicago, a little bit more baseball country. We haven't had a professional football team since I think about 1985. So I'm just saying that, okay. And I was trying to explain to him, I couldn't believe he didn't really understand baseball. We're at a Cubs game. I'm like, okay. So if I were to start to explain how to someone brand new who's not really familiar with baseball, which I never thought I'd have to do in my life, but okay. If I started this way, hey, so look, the pitcher throws the ball, the batter tries to hit the ball, run around the bases. So far, so good? And then what if the next thing I said was, okay, here's the infield fly rule. The batter's automatically out on a pop-up with runners on first and second or bases loaded. Oh, and then I get to, okay, foul tip is a strike. Unless it's a third strike. Strike is a pitch over the plate. Ball is a pitch, not a strike. Oh, but a strike is any pitch. Can you sort of see the problem with if you were this other person trying to grok how this game is played? What do you think is wrong with this? I broke it into little pieces, did I not? What do you think is wrong with this kind of instruction? Yeah. That's awesome. That's right. What else? Yeah, in the back. There's no information architecture. Only at this conference would I get such a great answer. That's right. There's no hierarchy. There's no notion of context or importance or ordering here. What do you need to know now versus next? When I started programming, I was paired up with a senior developer who was using Vim, which I did not. Well, I was like, what is that? And the first thing was to show me a bunch of keyboard shortcuts for things I didn't even know what they were for. So it was great to pair up, I guess, with a senior developer at that point, but not really, because they were not at my level. And I wasn't ready for that information yet. So don't do this. Here's a good example. I was actually wondering about how this works over the summer, and so I did a little bit of research on it. I was always curious how the Mars rover gets around in an unknown planet. Especially back when Curiosity landed, they didn't really have Google Maps for Mars yet. So how does it work? And this is how I would explain it to you. There's 6 wheels powered by electric motors. It only moves like an inch a second. It's a big planet, people. It gets power for the electricity from solar panels, and it's got cameras to see where it's going. Okay, so I think this is a little bit better. If you're trying to understand something brand new, is there anybody here from NASA or actually knows how this works? Good, because I just made this up. But this is pretty much, no, it's based on facts. But so I had to think about how am I going to explain this to you, and I had to think carefully about like what's probably your first question, and then let me add the details later. I really learned this the best from Bill Nye the Science Guy. Anybody a Bill Nye fan? Okay, awesome. I remember this episode, though I cannot find it for the life of me on the internet anymore, but he was at the beach with some kids and they were talking about rocks and sand, and they had a jar, and the idea was there was a bunch of sand and some stones and some really big rocks, and the challenge was to fit it all into this glass jar. And this is how it kind of came out. And it's like, okay, well, I guess there's too much stuff to fit inside of that jar. But that wasn't really true. The problem here is the order. So what they did actually was they took everything back out. They put the big rocks in first, filled up the bottom of the jar, then the stones on top of that, and then they could just pour the remaining sand, which would fill in all of that extra space and volume in between all the cracks there. And so when they did that, they ended up with something you could actually put the top on. And this is another way of thinking about why just breaking a problem into pieces is not sufficient. Order matters. This is what I call the big rocks first. Is when you're learning something new, you need to lie to yourself a little bit. Start with the main and plain ideas and just get those down. And then you can move on to the edge cases, the details, the exceptions. If you deal with those things at the beginning, it can be very difficult to get everything into your head, into the jar. Those of you mentoring or teaching, you got to keep this in mind. When you're starting with where your student is at, think about what's the next biggest rock I can put in. And if it's not entirely true because you know of all the exceptions, that's okay, you lie. You lie for a while. You let them just live with that lie until you say, actually, okay, so there's a couple things. But that's when they are then ready for those details. They are not ready for those details until they've got the main idea first. Okay, here's lie number 2. This is the last lie that I'll cover. That learning is like climbing a ladder one rung at a time. I don't know if you've been subject to this. Again, this feels like kind of makes sense. You want to start somewhere and just take your time, and it's kind of like breaking something into pieces, but you sort of want to start at a level 0 and then go to level 1 and level 2. And again, this is a common kind of learning technique. That is not really the entire truth, and it kind of just doing this doesn't quite work. And let me explain what I think is missing from this kind of explanation. The good part is that there is an order, at least, like in a ladder, there's at least some notion of order, which we did not have before when we just said, break a problem into little pieces. But here's what's missing. And it's a surprising, this came to me late in my teaching career, that what's missing is a notion of time. Let me try to dig into this and why this is so important, and a little bit counterintuitive. So a lighthouse is the best example I can think of. And I thought, you know what, I'm coming to Boulder. Let me get some pictures of lighthouses. No, so this is not a local lighthouse, but I think serves the purpose. There's, you got at some point somebody's got to change the light bulb up there. There's probably a joke about how many anyway. So there's a ladder going up the side. If I zoom in on that, so you have a big task in front of you. You have a big problem in front of you. You could take the advice of, just take the ladder, go one rung at a time, and eventually get there. And it's true. But how do lighthouses really work? How do they really get up there usually? If you could open this up, there's actually a spiral staircase in almost every lighthouse. And I think this is a great analogy for thinking about how to learn something complex. What's different between this and the ladder, you're still going to start at the ground level, you're still going to take one step at a time. But you're not just trying to go straight up. So let's say that the side facing us here in the lighthouse is, let's take a random, let's say Rails model. Let's say you're learning about Rails models for the first time. The first couple steps there might be, okay, look, it's a class, but it's going to connect to a table in a database. That's like good enough for now. And then you should continue up that spiral staircase, learning some other things about Rails. Get a little bit of Ruby under your belt. Learn a little bit of how to start and stop the server. Okay, and eventually you'll come back around like models again. And maybe the next time you come to that same side of the staircase, like, okay, models can be connected to other models. We call them associations, and you can start to like connect those up. Then you should do some other things in Rails. Give yourself time to just cope with that idea. What the heck is associations all about, really? And as you get higher and higher, now you're ready for scopes. Now you're ready for custom methods on. Now you're ready for what lambdas are inside of a scope. But you can't start with that stuff at the bottom, And it's this passage of time where you come back around and around again to the same topic that is so key to really learning. It's very hard to learn all about Rails models in one go. I don't know why books are organized like this. Some of the better books don't do that. They actually take you through more of building an app a little piece at a time. And what I'm identifying from that pattern is they're using, whether they know it or not, this kind of spiral staircase idea on you, so that you're not faced with learning everything at once on a given topic. You get the time to let your brain understand that, have questions about it. Anyway, so, but I want to be clear, there's a, at least in my LinkedIn feed, I, for some reason, got exposed to a lot of what people call spaced repetition. And this is a known technique in the learning sciences, which works pretty well. But it's more like flashcard style for memorizing things. It's when you're trying to remember something for a test. It isn't so much, I don't think, about understanding, although you could get some more understanding through this. So in case someone out there is thinking, hey, spaced repetition is the same thing, it's really not, because spaced repetition has no sense of elevation, and that's what we need to do when we are learning something complex. Sure, start one rung at a time, but give yourself time between rungs, and that's what's often, I think, overlooked in a lot of curricula. Okay, I think that's all I need to say about that. So just remember that spiral staircase. When you're really just trying to learn a whole new framework, something totally new, give yourself the time. Don't try to learn it all at once. Okay, so if I had 3 more hours, I would keep going. What I'm trying to do is just write down everything I've learned. It'll be free for the community sometime in 2026. And I would love to be able to hear on Slack or after the conference your personal learning experiences. What's been good? What's been bad? What could we do better in our community so that our number one job kind of gets easier? There are 3 pivotal moments in my life where I went from heads down software engineer to someone who cares about the education and the learning space. I can't recommend Pragmatic Thinking Learning enough. Andy Hunt, 2008. It's written for everyone, but he kind of knows most of the people reading are going to be developers. So there's some computer examples in there, programming examples. Sir Ken Robinson in 2013 blew my mind. I think this is still the #1 viewed TED Talk ever. Now, he did a follow-up, which was not so good. So just look for the original 2013 one. Dan Meyer, I've discovered this TED Talk also around 2013, but he had recorded it in 2010 at the local New York TED Talk. A math teacher talking about how to reimagine math class in K through 12 just was inspirational to me in how I would go about my teaching career. So if you're looking for three good sources other than this right now, I would definitely go for one of those three. So let me come back to this one. Remember this? Always learning new things is the key to a successful career. So hopefully now when you see this kind of cliche, you can sort of understand that there's more to it than just say, go learn it, right? This is complicated. And I just want to end by saying, like, look, we've all been on the other side of this. We're waiting for the right tutorial, the perfect boot camp, someone to explain it the right way to us. But here's what changes when you get better at learning itself. You stop becoming a consumer of other people's knowledge. And you begin becoming a creator of your own understanding. That Rails app you've been afraid to refactor, that language you've always been curious about, the career pivot you've been putting off, you're like, I don't want to start all over again. When you can truly learn your own learning process, those are no longer walls, they are options. Because you no longer feel like you're stuck with whatever you happen to learn first or whatever your current job is demanding. When you feel like you can learn new things, that's freedom. Like, I know this is not an AI talk, but there's a lot of uncertainty right now in our community. And I started to feel like, oh no, what's going to happen to me? But I have to remember, I've learned how to learn. I think a lot of us have. We're all somewhere on that spectrum there. And that is freedom. When you have learned how to learn new things, we do not need to be afraid about what's coming next. We can actually kind of look forward to it. We have the freedom to choose what we're going to spend our time and endeavors on. And when you can do that, you now have a reliable way to transform yourself again and again and again. And it's joyful, it's fun, you just keep going. And when all the individuals in the community do so, the whole community can transform itself from time to time and get renewed. And that's my hope for us. Thank you very much. A couple questions, if any? Yeah, in the back. Yeah, let me see if I can rephrase that and you tell me if I'm tracking you correct. I think the question is mostly about terminology and the vocabulary and the phrases that are used when we're trying to learn something new. Is that kind of in the ballpark? That's a, yeah.
Trying to go into a new area with the definitions you have.
Yeah.
It's kind of like setting yourself up for failure.
Yeah.
If they're using words that you don't know,
So,
stop.
yeah, excellent point. So every domain has a language unto itself, right? I remember when my kids were going through high school and they were in a class and they had terms that was like work, force, and it could be like, you mean like going to work, or you mean like Darth Vader? Like, no, it's physics class, right? So I'm an aviation enthusiast, and I've tried to pick up the terminology in air traffic control. It's crazy. Every industry that you work in is going to have its own terms. And the same word is going to have a completely different meaning when you switch jobs. So you go to some new industry or some new domain. And I think it is a huge hang-up. When I got into a healthcare space for a while, there were terms that I thought I knew what they were, and no one explained to me what they really were. And then I was like, oh, I wish someone had told me that a year ago. So I think it's very helpful when you are starting something new. Don't let someone give you an acronym without explaining it. This happens to me all the time. They just mention some acronyms. Thank you. And like, you gotta hold them down and say like, wait, what does that mean? And make them tell you what it means. Just play rubber ducky on them. And that'll be good. Awesome question, thank you. Yeah.
Same thing, I'd like to point out, I'm in healthcare.
Yeah.
Our acronyms
Awesome. Okay. Gotta stay current. Yeah, that's a great point. Gotta stay current even within your own industry as things change. Yeah, Jason. Yeah, if I could just tag on to onto that, Clayton Christensen, I think he was the Harvard Business School. I was watching a talk years ago. He once had a great quote that I would love to share with you all. He talked about the value of questions. Now, this is going to be weird, so hang with me here. He said, questions are places in your mind where answers can fit. And if you don't have the question for something first, you might enjoy that podcast or that book or whatever, but it'll just kind of bounce off. Like 3 days later, you may not even remember what it was about. But if you happen to come to this talk, let's just say, with a question about how do I learn more, right? Then this would have landed even better. So in school, we do not reward questions, we reward answers, don't we? Who's got the answer? We should instead be rewarding how good a question can you come up with for investigating something. And that's what I think we should also be doing in our jobs. Let me do one more. Yeah, in the back. Great. So the question I think is kind of how do we connect this idea of passion with things you have to learn? Is that fair? Or okay. That's right. You've got to be motivated for one reason or another, or it's not going to happen. I was not motivated in school. I did not learn very much. I mean, just to be honest, right? I was not into it. I just wasn't ready for it. I think that somehow when I become curious about something, and I don't really know how that happens, but like, with this Mars rover example, like I've been a fan of the Apollo space program for a long time. I got curious, like how does it actually drive around? Because I'm naturally passionate about space and what's going on there. Then that provided the motivation I needed to get through the slog of learning that thing. Becoming a software developer is pretty much impossible these days unless you are really motivated, because it's so hard right now to get in. You need some sort of passion or personal project or something that you have to make happen to just get you through the hard parts of learning. And so I think they very much go together. I think you can't really learn too much if you don't have some internal, intrinsic motivation to learn. Too much of our education is extrinsically forced, and the kids don't really have a chance to figure out what they want to learn about, what they're naturally curious about. That's where the learning would really happen. All right, if you want, I would love more questions anytime the rest of today or tonight. Thank you so much.